Hello, everybody. Welcome to the Arithmetic Zone. This is going to be our first video in our series about the unit circle. So, in order to understand the unit circle, we have to understand the properties of two special right triangles, this one being the 45-45-90 triangle. And at first, it may seem weird that we have to know what a triangle or the properties of a triangle in order to understand what a circle is, but it will all make sense in the coming videos. So, for now, let's just look at this example. We're going to consider the following isosceles right triangle, whose hypotenuse is equal to 1 and whose angles are both 45 degrees. And we're going to solve for x. So even though we only have one unknown, or one known value, I should say, the other two unknowns are actually equal to each other. So we can use the Pythagorean theorem. Our a squared plus b squared is equal to c squared. And so we're going to have x squared plus x squared is equal to 1 squared. And this is how we're going to find our unknown side length of x. And so we're going to simplify this a little bit to get 2x squared is equal to 1. We're going to divide both sides by 2 to further isolate x. We're going to get x squared is equal to 1/2. And now to deal with that exponent, we're going to take the square root of both sides. And we're going to get x is equal to, and I'm actually going to rewrite this radical as the square root of 1 over the square root of 2. These two are equivalent statements right here. And I did this so that it'll be easier to solve. And so we're going to have x equals, well, the square root of 1 is just 1. And the square root of 2 doesn't really have a nice way of simplifying it, so we're just going to leave it like that. But in the math world, we don't really like to have square roots in the denominator. So I'm going to rewrite this 1 over square root 2, and I'm actually going to multiply it by the square root of 2 over the square root of 2. This is a process known as rationalizing the denominator, so we can get rid of the square root there. And this is just 1, because any number divided by itself is still 1. So we're not actually changing the value of this number. We're just changing how it looks. We're making it look better. So multiplying straight across, we get the square root of 2 over 2. So we have x is equal to square root 2 over 2. And that is the length of these sides of the triangle. So now let's look at our next right triangle, the 30, 60, 90. We're going to consider the scalene right triangle, whose hypotenuse is equal to 1 and whose angles are 30 and 60. And we're going to find the length of both sides. So this one is different because these two side lengths aren't equal. We can't as easily use the Pythagorean theorem. These are like two different variables in x, y, for example. So what I'm going to do is I'm going to draw this same exact triangle just in the opposite direction. It's almost as if you're looking into a mirror. And this triangle is going to have all the same properties as the one on the right. We're going to have this 30, whoops. We're going to have this 30, the 60, oh, that's not a 60. This is going to be our right angle and our 60 degrees right here. And we're going to do this so that we can work with this big triangle. And this big triangle will make it easier to solve for our two unknowns. So in the big triangle, we have our 60 degrees here, our 60 degrees here, and this angle, the 30 plus the 30, is also 60 degrees. So what that tells us about the big triangle is that it's actually an equilateral triangle, meaning that all the side lengths are equal. So that means that this side length is equal to 1. And this line right here cuts these two triangles in half, which means that these two sides that I just marked with those little lines, let me do that in a different color actually. These two lines are equal. And so we're just going to do 1 divided by 2, which is going to be 1/2. And so this side length is going to be 1/2. And this is also going to be 1/2. So I'm actually just going to redraw the triangle right here so that it's easier to see. This is our original triangle with the 30 up here, 60 right here, 1. But we actually now know that this is 1/2. And so now we only have one unknown. Found the length of one side, and now let's find the length of the other, shall we? We're going to use our Pythagorean theorem. A squared plus b squared is equal to c squared. and we're going to have x squared plus 1/2 squared is equal to 1 squared. And this 1/2 squared, it's the same thing as saying 1/2 times 1/2. Multiplying that straight across is 1/4. So we're going to have x squared plus 1/4 is equal to 1. We're going to subtract 1/4 on both sides to isolate that x. We're going to have x squared is equal to 3/4. And similarly to our previous example, we're going to take the square root of both sides. So this is going to be equal to x is equal to square root of 3 over the square root of 4. Square root of 3 doesn't have a nice number that it simplifies to, but the square root of 4 is 2. And because there's no radical in the denominator, we can actually stop there and we can have this as one of our side lengths and this 1/2, I'm going to just highlight that one, as our other side length. And those are the properties of the special right triangles. If it's a 30, 60, 90 triangle, the side lengths are going to be 1, 1/2, and √3/2 respectively. And if it's a 45, 45, 90 triangle, and the side lengths are going to be 1, and then the other two are going to be the square root of 2/2. And right now, these might seem like arbitrary numbers, like why do we do this? But these are going to be very important in helping us build the unit circle. So this is a shorter video just to introduce you to these triangles so that it becomes easier, so that the work ahead becomes a little bit easier. Thank you so much for watching, and I hope you have a great day.